Hey statisticians, so hopefully you found your notes and printed them out and you're ready to do chapter 6. As a matter of fact, the next two chapters will be about probability and random variables that are produced as a result of probability. So first let's talk about what probability is. I'm sure you have a little bit of a notion. Statistics Kitty's joining us today. He's going to help. So probability is the long run happens over time. Relative frequency, and remember relative simply tells us that it's in percentages. So, of course, chance behavior is very unpredictable in the short term. That's why Vegas is so much fun, right? Because people think, ooh, I'm going to get lucky. Oh, I guess I was spelling that right, unpredictable. So I'm going to wager it all. But it has a regular and, as a matter of fact, predictable pattern in the long run. And of course, people think that foul shots are actually dependent, but of course, over the long term, I can predict whether a player will make shots based on their relative frequency, but in the short term, every basket's unpredictable. Okay, so random does not mean haphazard. That's very important. It's not just random crap or random chance. It's actually a description of order that emerges again over time. So in the long run, but to see the pattern, we have to have a long series of independent trials. And when we were talking about simulation, remember one of our assumptions was independence. That independence is very important. Independent. Be helpful if I actually spelled it correctly. Let's fix that. There, better. And so, of course, remember that theoretical is from a formula. So we calculate probabilities based on formulas that we know. And those are generated because of somebody trying a long series of independent trials frequently, versus empirical is just from doing the experiment ourselves. So experimental, empirical, they sort of sound a little bit alike. Okay. For example, theoretically, I know that the probability of heads is a half every single time, but I could actually do an experiment, flip a coin 10 times, and get heads 7 times. That doesn't mean that the probability of heads is now 70% and tails is only 30%. So our sample space, we call it S, contains all the outcomes for the experiment or the trials. And of course, the probability of the sample space must total 1. And an event is nothing more than a synonym for an outcome. So we'll call them outcomes or events. And then you've seen multiplication principle before, that if you can do a task, one task in A ways and another task in B ways, then both tasks can be done in A times B ways. And again, we'll assume they are independent. So for example, if I have 3 pair of socks, 5 pair of pants, and 10 shirts, so the would be 3 times 5 times 10 for a total of 150 outfits. See, your parents overshop for you. And then if I go down to 31 flavors, and I have to pick an ice cream and a sprinkle choice and a sauce choice for my sundae, then I have the option of getting one of 372 sundaes. Ooh, that'll last me for well over a year to get a different sundae every day.